Hey guys, today I'm going to go through Unit 6, Lesson 4 on acid-base titrations and pH. There are some math-based problems in this lesson that you may need help with, and then they also are going to be all over your quiz that's coming up next. And so watching this video will not only help you make an A on your lesson, or as you'll get all the ones right that we go through at least. And it also will help prepare you for your quiz because the quiz is going to cover the exact same content as far as the math questions go. One thing is that you should pull up these slides. These slides are in your resource folder. And then something else that you can pull up is, I was thinking of one other thing. I don't know what the other thing was that I needed you to pull up. So one thing that you should pull up while you're going through this are the Google Slides that I'm going through here, which are linked in the YouTube description, and they're also in the student resource folder. So have that pulled up. And then you also want the equation sheet for Unit 6, which is also linked in the YouTube description and also in the resource folder. So you need the equation sheet and you need these slides just to kind of go through them as well. And so the first thing math-based from this lesson talks about water. And so just to go back, pH is measuring like the content of of hydrogen ions. And the more hydrogen ions that something has, the more acidic it is, or the lower on the pH scale. So this pH scale goes from 1 to 14, and 14 is the most basic, and 1 is the most acidic, and 7 is neutral. Okay. So as you go down, the H plus concentration increases. As you go up, the hydroxide, this is called hydroxide concentration, increases. So it's like this sliding scale. If one goes up, the other goes down. Water is really special. So I want you to look at what happens here. This is kind of weird. So first you see two regular H2O molecules, right? At the very beginning, it's H2O. And then what happens? One of them becomes H3O right there, and one of them becomes OH negative. Like it just is just one of them, just one H, or HO. So actually at a microscopic level, this is what's happening to water. When you have, like I have this glass of water right here, this is not actually purely H2O. There are some H3O ions in here and some OH negative ions in here. Water is reacting with itself. Isn't that crazy? So water is constantly reacting with itself in order to form some H3O and to form H2O. This is showing it a little bit differently. This is what's happening in water all over right now. It doesn't, like, there's a small amount that turn into these two things, okay? And it's called ionization. And so what happens is it forms, regular water reacts and it forms H3O and OH negative, okay? So there's some math with that, that an equation kind of comes from that. So basically, when you have high H plus and low OH, it's acidic. If you have high OH and low H plus, it's basic. And you can write that into this formula right here, that there's a certain constant. It's called the ionization constant of water. And that is equal to the H plus concentration times the hydroxide concentration, always. And that constant is always this number, 1 times 10 to the negative 14th. So 1 times 10 to the negative 14th is always going to equal the concentration of those two things multiplied. And you're like, what on earth? What does that mean? What does that even mean? So I want to explain it. What that means is, like, if you have a large H plus concentration, you're going to have a small OH concentration. Or if you have a large OH or hydroxide concentration, you're going to have a small H plus concentration. Or you might have it, which would be soap. That would be, so for example, the top one would be acidic because it's more H plus, and the bottom one would be basic, like soap. Or you could have an exactly equal amount. If it's exactly equal, if the concentrations are exactly equal, then you're neutral and you have water, just pure water, okay? So when the concentrations are equal, you have to have pure water. So all that being said, the math equation for that, I'm going to share my little Jamboard here. Here is the math equation for that, which you can find in the equation sheet, but we are going to use this. So basically this is always equal to this times this, okay? Or you can write it like this, H plus times OH. H plus and H3O plus are kind of interchangeable with one another when it comes to acids. So this equation we're going to use, and we'll do some problems like that in just a second. But there's one more equation that you have to know. You have to know how to calculate pH, and pH is actually really easy. So this is the easiest part, so don't get overwhelmed by it. pH is calculated by taking the negative log of H3O plus, the negative log of it, or the negative log of H plus, because those are the same things. You might be wondering what a log is, but guess what? If you have a calculator or if you have your online scientific calculator, you just have to punch in the log button. You don't have to know what a logarithm does. You just have to know how to punch it into a calculator, and I'll show you how to do it. So pH is the negative log of H3O plus. So I'm going to show you my screen on that. I have that slide here. So pH is the negative log of H3O plus, and it ranges from 0 to 14. Or sometimes they give it to you reversed, and they give you the pH, and they want you to find the H3O plus. And if so, the reverse of that is that to find H3O plus, you take 10 to the negative pH. So for example, if your pH is 13, then to find the H3O plus concentration, you just do 10 to the negative 13th, and you punch that in your calculator, and your calculator will give you an answer, and that is your answer. So literally all you do is you put it in the exponent of a 10, and that gives you H3O plus. So we'll actually practice with it because I know it's like a lot of information. So let's start with problem number 10 on your lesson. It says a hydrobromic acid solution has a molar concentration of 0.0085 m. Okay, so what does that mean? It says that HBr's concentration is 0.0085 m. That's telling you how potent it is, how concentrated it is. The M is a measure of concentration. Is HBr an acid or a base? Well, if it has an H in it, it's going to be an acid. And if it has OH in it, it's going to be a base. So HBr is an acid. And so this is equal to the H3O plus concentration because it's an acid. And so this is already part of our answer. The H3O plus concentration is 0.0085. It says calculate the H3O plus concentration, the OH minus concentration, and the pH. So whatever, if it's an acid, this number is the H3O plus concentration. For the OH, we have to do some math. Remember that we have that formula that Kw, which is always 1 times 10 to the negative 14th, is equal to H3O plus times OH negative. Well, we know what H3O plus is, right? It is 0.0085. So I can plug that in. 1 times 10 to the negative 14th equals 0.0085 times OH. So OH is like our X. We're solving for X. Right now, X needs to be by itself, and it's being multiplied right now by 0.0085. We can undo that by dividing by the same number, and then it will cancel out. But what I do to that side, I need to also do to this side. And now I need to do the math here. In my calculator, I need to do 1 times 10 to the negative 14th divided by 0.0085. If you struggle with punching that in the calculator, I will be so happy to help you. If you join my classroom, or any teacher will be happy to help you with punching that in the calculator. So that divided by that is 1.18. I'm kind of rounding it off, times 10 to the negative 12th. Okay, so your answer on your answer key should look close to this. Okay. And then for this one, they may want you to have it in scientific notation, the 0.0085. You could shift it over. I'm not sure if they do. If so, then it would be 8.5 times 10 to the negative 3, because we're shifting 1, 2, 3. I'm not sure if your answer is supposed to look like this or supposed to look like this, but the H3O plus concentration is 0.0085, which is the same as 8.5 times 10 to the negative 3. And then lastly, they want us to calculate the pH. pH is the negative log of H3O plus. So let me show you how easy this is to put this in the calculator. So what is our H3O plus concentration? When we look here, it's the negative log of 0.0085, right? So we need to put that. That's the H3O plus concentration, right? Because that's this right here, H3O plus. We need to just put that in our calculator. So I like to use the Desmos scientific calculator, and you can just type in on your keyboard negative log parenthesis, and then type in the concentration, and make sure you do put it in parentheses, right? So you just type in log and it'll do it for you. And then this is our answer, 2.07. I'm just going to keep 3 digits, 2.07. I don't know how many digits they ask you to keep, but I'm going to just make that 2.07. So there you have it. We've calculated all 3 that they've asked for. Okay, let's look at number 11. Is this the same? I guess they're giving us a slightly different numbers. So again, we have a hydrobromic acid solution, HBr. That's an acid, right? Acids have H in them. So this is equivalent to the H3O plus concentration because it's an acid. Acids have H3O plus. And that is equal to 0.055 M. Okay? We need to calculate 3 things. The H3O plus concentration, the hydroxide concentration, and then lastly, we need to calculate the pH, okay? Well, for H3O plus, we already have the answer. It's 0.055 because HBr is an acid. They may want you to put it in scientific notation. If so, we can shift it over 2 times to make it 5.5 times 10 to the negative 2 M as our answer. Either way, these are the exact same numbers, okay? For the OH concentration, we can get that because we know the formula, Kw equals H3O plus times OH negative, okay? Kw is always this number. So 1 times 10 to the negative 14th is going to equal, and then H3O plus is 0.055, right? And then OH negative is like our X. So right now, our X is being multiplied by 0.055. So we need to, I'm going to write really small here, we need to divide both sides by 0.055. So divide by 0.055 so that it cancels out here. And what I do over there, I have to do over here. So in my calculator, I'm typing in, and I'll just show you if you want, right here. I'm typing in 1 times 10 to the negative 14th divided by 0.055. And I get 1.818181812 times 10 to the negative 13th. I'm going to just round that to like, let's say 1.8 times 10 to the negative 13th. So in this situation, our X, which is hydroxide, is 1.8 times 10 to the negative 13th concentration. Okay. Let me double check that. Yep. Okay. So that's our answer there. And lastly, pH is always the negative log of H3O plus. Okay. So our H3O plus was the 0.055. So we just need to type in negative log of 0.055. And I get 1.26 if I want to round that off. I don't want to write down all of those. So I'm going to keep just these 3, and then that 9 bumps it up from the 5 to a 6. So it's going to be 1.26. So the pH, just as a reminder, that's really acidic. It's a pH of 1. That is very, very dangerously acidic. It's really low on the pH scale. And that makes sense because our H3O plus concentration was pretty high, and our OH concentration was pretty small, really, really small. Okay, problem 12. A potassium hydroxide solution has a molar concentration of 0.026. Calculate the H3O plus concentration. Calculate the OH minus concentration. And then calculate the pH, okay, of the solution. So right now it gave us potassium hydroxide. If it has OH in it, this is a base. Acids have H in it at the beginning. So like HBr. H's at the beginning typically refer to an acid. Hydroxides at the end mean that it's a base. And so this is not equal to the H3O plus concentration. This is equal to the hydroxide concentration. So this is our answer to this part right here because it's a base. Okay, bases correlate to hydroxide. Acids correlate to H3O plus. This is also called hydronium. If you want to sound cooler, H3O plus is called hydronium. So 0.026, they may want you to put it in scientific notation by shifting 1, 2. So 2.6 times 10 to the negative 2. This is a pretty strong concentration of a base there. So now we need to find H3O plus. We know that Kw equals H3O plus times OH negative. So let's plug in what we know. Kw is always 1 times 10 to the negative 14th. Our H3O plus concentration, we don't know this time. It's like our X, but our OH concentration, we do know. It's the 0.026, right? So in order to get that X by itself, we need to divide both sides by 0.026. And so we're doing 1 times 10 to the negative 14th divided by 0.026. It is important to know how to type this in yourself. So try practicing this too. I'm getting 3.8 times 10 to the negative 13th. And I'm just going to round off at 3.8. So this is X, which is H3O plus, is 3.8 times 10 to the negative 13th. Okay. For pH, pH is always the negative log of H3O plus. It's always going to be the acid, the H3O plus, not the base. So again, it's going to be the negative log of 3.8 times 10 to the negative 13th. This is a really small number, 10 to the negative 13th. So we have a really small amount of acid. So negative log of 3.8 times 10 to the negative 13th. I'm getting 12.42 as our pH. Our pH is 12.42. Well, the highest that pH is allowed to be is 14. pH is always from 0 to 14. This is very basic. This is very strong. This would be like oven cleaner or like drain cleaner, really, really strong if it has a pH of 12. Or bleach. Bleach has a pH of like 10 or 11. And so anyways, just it kind of helps you understand what you're dealing with there. Okay, number 7, a solution has a pH of 8. Okay, so it gave us the pH. Calculate the H3O plus, the OH minus, and that's all. It just wants us to calculate those two things. So H3O plus and then OH minus. Okay, well, what can we do with the pH? We know that pH is the negative log of H3O plus, right? So how do we like find H3O plus? Well, like I said earlier, if you want to rearrange and solve the other way, then the other formula is that H3O plus is equal to 10 to the negative pH. That's how you rearrange the logarithm. Logarithms are kind of weird. So to rearrange that logarithm and solve for H3O plus, it's 10 to the negative pH. So 10 to the negative 8.00 should tell us the H3O plus concentration because our pH is 8.00. So I'm just going to type that in my calculator. 10 to the, what was going on? 10 to the negative 8th. And my answer is simple, just 1 times 10 to the negative 8th. So my H3O plus concentration is 1 times 10 to the negative 8th. To find OH, I can use that relationship. Kw is H3O plus or hydronium times hydroxide, right? So 1 times 10 to the negative 14th is Kw. And then our H3O is 1 times 10 to the negative 8th. And then this is our X. So we need to divide both sides by that to get X by itself. So there's more exponents here. It's a little bit harder to do. So you can look at how I do it here. I'm going to do like parenthesis like that, and then click divide, and then do another parenthesis to make sure that everything is where it needs to go and make sure that I don't mess anything up. And I get 1 times 10 to the negative 6th. So that is my concentration for OH minus. And that makes sense because, yeah, 1 times 10 to the negative 6 times 1 times 10 to the negative 8, that will add up to be 1 times 10 to the negative 14th. So that's so in this situation, we had to do 10 to the negative pH to find H3O plus, which is another cool tool that you can do. You can always find H3O plus by doing 10 to the negative pH. Okay, last one here. Okay, last one here is on the topic of titrations. And so I'm going to talk about titrations by going back to this tab. Titration is a way to basically, it's a really cool thing. When you have a lab where you can actually do this, titrations are actually really cool. Basically, if you have a solution that's in this pipette right here, and another, like, let's say that what's in this pipette is an acid, and then whatever is in this Erlenmeyer flask is a base. You can slowly, drip by drip, add the acid to the base until they neutralize and turn. You have a chemical in there that makes it turn a certain color. And what this is useful for is basically if you don't know the concentration, like you have an acid and you don't know how strong it is, you can figure out how strong it is by determining how many drops of the base that it took to get there. Like if it takes a ton of base to neutralize it, it's probably a really strong acid. If it only took a little bit of the base to neutralize it, then it might not be very strong. Like it's really weak. And so titration is a way to determine the concentration of an unknown solution. Titration is just the way to determine the concentration of an unknown solution. And there are a few steps on how you do this, and you will have these questions on your quiz and on this lesson. So the first step is to write the balanced equation. So let's read the problem. A 25 milliliter solution of nitric acid, which thankfully it gave us the formula. And if not, you can always Google it. Google nitric acid and it's going to come up. It reacts with, so I'm doing a plus sign, with an unknown concentration, with a solution of nitric acid with an unknown concentration is titrated with a solution of lithium hydroxide. So it's titrated with lithium hydroxide. Calculate the concentration. We need to figure out what the products are. And when you have an acid and a base, what happens is this is our acid. It has an H. And this is our base. It has an OH. The acid is going to swap up and it's going to donate a proton. And so what basically, they kind of all swap partners. And our products, hold on. Yeah, our product is going to be LiNO3. The Li goes with the NO3. Like the positive part here goes with the back part, the negative part here. And what's left over is H2O because it's like this part with this part. And that makes H2O. And so you can always look this up online if you need to. Like if you add these two together, Google will help you with the products as well. I know it's kind of hard to figure out what the equation will be, but you can look it up. And then we need to make sure it's balanced. And I think it already is. Like we have 3 oxygens here and 3 oxygens here, 1 lithium here and 1 lithium here. We have an O, an H, and an H right here. And then an O, an H, and an H. Like if you add everything up, it's the same number on both sides. It's already balanced. Now we need to find moles of the known substance. So our unknown substance is HNO3. It says that it has an unknown concentration. Okay. We need to find the moles of the known substance, which is LiOH. Okay. It said that we had 12.5 milliliters of it and that its concentration was this. I'm just copying that down. Well, we can convert that over to moles because molarity, or capital M, is equal to moles divided by liters. The concentration of something is how many moles are in it divided by the volume. Okay. Our molarity, or capital M, is 1 times 10 to the negative 4. So I'm going to plug that in for our M right here. Okay. Our moles, we don't know. It's like X, right? And our liters, we do know because we have 12.5 milliliters. You can divide that by 1,000 to get to liters. Milli means 1,000th. So we can do 12.5 divided by 1,000 and convert that over to liters, right? So you just divide by 1,000 to get it into units of liters. And that's what goes here. So we need to solve for X, and this is moles of our known substance, which is LiOH, right? We need to get that by itself. Right now it's being divided by 0.0125. So to undo that division, we can multiply by it because see how that's on top and that's on bottom, so it'll cancel out. And then what I do to that side, I also need to multiply on this side. So I need to do 0.0125 times 1 times 10 to the negative 4th. So I'm just doing this times that right there. And that is how many moles of, this is how many moles of lithium hydroxide I have. So I figured out how many moles of my known that I have. Okay, and I'm going to copy that over right here. So this is how many moles of LiOH that I have. And I'm going to convert that over to moles of my unknown. Remember that my unknown is HNO3. Its concentration is unknown. So I'm going to convert it over to moles of, this is moles of LiOH, by the way. So moles of HNO3, you put what you want to get to on top and what you want to cancel out on bottom. And I want the LiOH to cancel out. The way that I input the relationship here is I look at my equation here. There are no coefficients. It's not like there's like a 2 or a 3 here. And so that means that like there's an invisible 1 right here and an invisible 1 right here. It's already balanced. There didn't need to be any coefficients. And so it's just a 1-to-1 relationship. So it's just 1-to-1. So really it's the same number. That times 1 over 1 is going to be the same. But this is how many moles of HNO3 I have. And it asked me to find the concentration. Concentration is molarity. Concentration means molarity. And molarity is the moles that you have divided by the liters that you have. Well, I just figured out the moles that I have. It was 1.25 times 10 to the negative 6. And then the liters that I have, let's go back. It says that it's a 25 milliliter solution, 25 milliliters for the nitric acid. So if it's 25 milliliters, I can just divide that by 1,000 because for every 1 liter, there's 1,000 milliliters, right? That cancels out. So 25 divided by 1,000, that's how many liters I have. Okay, so I just need to do 1.25 times 10 to the negative 6 divided by 0.025, and that gives me my concentration, my molarity, which is moles divided by liters. So in summary, what I did was I wrote the balanced equation, and then they gave me some information that I had to kind of manipulate. They gave me the known information. You take that known information, the molarity and the volume, and you solve for the moles of that known solution, of that known substance. And then you convert the moles of your known substance to moles of your unknown substance, which typically is the same. Like typically it's like a 1-to-1 relationship. And then you take those moles and divide them by the volume of your unknown. And they will always give you the volume of your unknown. And they will basically always give you this information as well. So it's going to be in this formatting every time. Just make sure you read it carefully and kind of parallel with this example problem here. And if you need to work another titration problem, I'll also link other examples in the playlist below so that you can watch some more and feel like you have more of an understanding, because I know this is a lot of information. And so if you have any questions, please watch the videos after, and then you're always welcome to come to my classroom. You're always welcome to ask questions and to get help whenever you need it. Have a great day.